We are back with the next activity, which is coming from the Faculty of ICT. And what we have is a Shark Tank pitch by research students from the same faculty. The Faculty of ICT provides higher education of quality to meet the needs of today's industry and that of the future. Students learn specific principles on how these can be applied to solve real-world problems. Moreover, they are prepared to become leaders in today's digital world. What is being presented in this session is a selection of 4 final year projects at undergraduate level. We are sure that you will find them interesting and inspiring. So, let's go with the first pitch. We have Lara Brockdorff, and she will be joining us on Zoom. Lara is a recent graduate with a BSc in Computing Science. Her dissertation focused on an area of relationship detection within images, where comparatives between 2 objects in an image were explored. Let's hear more about this from Lara herself. Lara, are you with us?
Hi, yes, good evening.
Hello, good evening, Lara. How are you?
I'm well, thank you. How are you?
Fantastic. So, the pitch is yours.
Thank you. So I'm going to go ahead and give you an overview of my project. So yes, as was just mentioned, it is titled Detecting Comparatives in Images, and throughout this project, I was supervised by Professor Adrian Muscat. So a quick overview of who I am. As was mentioned, I am an undergraduate student who has recently graduated, and the context of this project is in our final year, we get to show off what we've learned by producing a piece of work that represents what we feel about our area. So my work focused on images. As we could tell, in images, we often have different objects, and between objects, we often, as humans, could describe a relation. For example, personally, while looking at this image, I could note that the teddy bear is bigger than the child. Although this is easy for me to do as a human, it is not easy for my computer or my machines to detect this relationship on their own. So my dissertation focused on identifying these objects within the smallest box possible. As we could see, the teddy bear is in a blue box and the baby is in a red box. And from the maths relationships, maybe things like the area, the differences between the areas of the objects, as well as what type of objects they are, I use different statistical models and techniques in order to detect these relations. An interesting part of this project relied on the fact that it was data-driven. So I did not tell my computer exactly what relationships features I want to detect. So I never said that if the area is bigger than the other, it is considered a bigger than relation, but instead I provided my computer with a lot of examples, over 1,000 examples of different relationships and images. From those relationships and the details between them, I was able to compute these models which were capable of actually predicting this relationship in the object. So that's a quick overview of what I did, and I think it was great fun working with images, and this task is something interesting as it could help people with different impairments who cannot possibly comprehend an image to have a description that would help them understand it. And it could also be used, since on the internet and in the world, the digital world we're living in, we have such a large amount of data and images. It could even help us create automatic descriptions, which will help querying and searching. I think that this project could help the area, especially since not much work on this type of relationship has been done before. Thank you.
Thank you, Lara. That was great. And we move on to our second Shark Tank pitch by Julian Demicoli. Julian is a BSc IT in Computing and Business graduate and carried out his final year project in credit card fraud detection with oversampling. Credit card fraud datasets suffer from an inherent problem, which is that they are highly imbalanced, and thus traditional machine learning classifiers struggle to correctly classify instances of fraud. Over to you, Julian. We need, Julian, I don't know if you can hear me. We need your microphone. Yes.
Okay, sorry about that. Let me just hide the panel.
Yes, we can hear you now.
Okay, so as we all know, online payments is becoming very popular. People are buying more and more from online e-commerce sites, and that is driving the amount of transactions which are happening globally with credit cards and other cards, debit cards, things of that sort. So we see, with increased transactions with this type, we're seeing an increase in fraud, so much so that credit card fraud is forecast to reach 35.67 billion globally by the year 2023, which is quite a high number, and naturally that should make the people who are interested in business conscious of the business opportunity in this area. With credit card fraud detection, we've had systems in place for many years, rule-based AI systems. However, the problem with rule-based systems is ultimately once you know the rule, you can break the system. So if you know that a trigger is flagged when an individual uses a stolen credit card, for example, in a country that is different from the country of that card, you simply just do not do that, and you break one rule, and you do not break the rule. So rule-based systems, they work, they're used in the industry, but we can do better. One has to think maybe we can use traditional machine learning classifiers to solve this problem, to correctly classify what is fraud and what isn't, based on the fine details in every transaction. Every transaction will have a lot of different features, and maybe we can classify them based on those features. But then we come to another problem, in that data sets of credit card transactions will only have a small amount of transactions which are actually fraud. In this project, in fact, over 99% of all transactions were legitimate transactions, and less than 1% were fraud. So, if you use a traditional machine learning classifier, you're going to have bias towards the majority cross, and even though you're going to have an accuracy of 99%, that means nothing because the data set is 99% fraud, non-fraud, excuse me. So if you label everything as legitimate, you get very high accuracy. So how do you solve this? Well, you can use a technique known as oversampling, which basically looks at the details, the features of every fraudulent transaction, and tries to imitate them and create synthetic data points. These techniques have existed for a long time, and one of the most popular techniques used is a technique known as SMOTE. But SMOTE has spawned many variations of it, and so this project seeks to examine, are any of the variants of SMOTE better than it? So basically what the project did was it took 5 of the top performing variants of SMOTE. The exact ranking varies according to the domain of the data set. So there was work done recently in 2019 by a man named Gregory Kovacs, who attempted to sort of classify these variants, of which there are around 84, but probably more now, in some sort of ranking, and I have taken the top 5. When we examine them based on this architecture, we can find that, in fact, SMOTE is not the best performing. Rather, a technique known as SMOBT performs better. And if we look at the results on a machine learning classifier point of view, we find that SMOTE is not even best if we use a technique known as XGBoost, or if we use Gaussian naive Bayes. In fact, other techniques perform better than SMOTE in these instances. As to future work and where this can be used, well, as I said, credit card transactions are becoming the popular method of payment. People go days without using cash these days. So, all of these new services that we are using underneath, where we cannot see in the back end, so to say, these systems are in place, and fraudulent people will always look for new ways of beating these systems. So we always need to try new techniques, new research into fooling the fraudsters. Thank you very much.
Thank you, Julian. And our third pitch is by Gabrial Camiller, who unfortunately couldn't be with us today, but he has recorded a message for us. But Gabrial Camiller is a graduate in Bachelor of Honours of ICT in Artificial Intelligence. The aim of this project was to research and develop a workplace assistant augmented reality application using image and object detection provided by Viewforia and filtered through user profiling, using Unity to build the system's architecture. Let's watch Gabriel's video. Thank you, Gabriel, for sending us that video. Now we go on to the fourth pitch by Anastasia Lauri. Anastasia has just graduated with a bachelor's degree in computer engineering. For her project, she decided to develop a sensor glove which can translate the alphabet sign language hand gestures and output the letters onto a computer screen using a wireless link. The aim was to allow a deaf person to communicate with someone who does not understand sign language. Anastasia, you're up.
Hi, hello everyone.
Hi.
So basically, my final project, I decided to do a sensor glove. I don't have a PowerPoint for you guys, but I built the glove. So I was supervised by Dr. Van Grek and Dr. Victor Buttigieg, who helped me out in this project. So basically, as you mentioned, the aim of this glove is to translate the gestures of sign language, the letters of the American Sign Language, and translate them into letters. They will be output onto the computer screen for someone who does not understand the sign language to be able to see, to understand. So basically, I started building with the sensors. First, I used the flex sensors. These sensors are used to be able to detect when you bend the letters. You bend the fingers. So when you bend the fingers, the resistance of the flex sensor changes, and this is noticed by the program, and it will detect the bending of the finger. I had to use 2 sensors on each finger to be able to detect the 2 joints, this joint and this joint, the knuckle, because when you're signing, you have different bending and different degrees of bending for each letter. Then I needed another sensor which would detect the orientation of the hand. So if it's in x-axis, y-axis, or z-axis, it would detect the rotation of the hand. Since in some letters, for example, the K is at this orientation, and the P, which has the same finger positioning, will be at a hand orientation, which will be horizontal. So that to detect between those 2 letters, you would need to know the hand orientation. I also wanted this to be wireless, so that there wouldn't be entanglement of wires between the glove and the computer. It would be portable. So I used the Bluetooth and the battery. These would be able to connect to your PC, and you'd be able to output the letter onto a computer screen. So the processor is in charge of everything, so it takes all the information from the sensors and it processes it. It sees like the degree of bending of the sensor and the orientation of the hand from the other sensor, and then it will process and join all that information, and it will see which letter falls under that category of the information obtained, and it will send the letter obtained through Bluetooth, and it will output it on the letter. This is obviously for someone, for example, before this project, I did not know sign language. I did not understand it. And this idea actually came to me. My sister had a friend from school who they used to learn how to sign to be able to communicate. And for someone like me who does not understand sign language, she could sign something using this glove, and I could read it from the computer screen, basically. So yeah, that was the whole project. Thank you very much.
Thank you. Fantastic. Those were some amazing presentations. Okay, so we have some questions for you now. Lara, let's start with you. We have a question for you. You mentioned the use of different models. Can you mention one of the models used and how it works?
Sure. So one way that the classification of the different comparatives was done was through a model known as KNN. This stands for the K nearest neighbors, where K could be any number. So the way it works is that from our boxes within our images, we could develop how close different samples are to each other. And we could take a sample of an image that we already know the classification of it, whether the objects within it are bigger than each other, smaller than, or any other respective comparative. And based on the closest number of samples around it, we take the new sample, which we don't know this classification of, and we would like to classify. We take the closest neighbors around it as the new classification of the unseen sample. So that is one technique amongst quite a few others, which others, for example, make use of logistic regression and different plottings of the samples, but this is one of them, which is quite a cool one, in my opinion.
Okay.
Thank you.
Thank you, Lara. So we have a question for Julian. How can your project be used in the real world?
So basically, when you think about it, you know, big firms like big banks like JP Morgan or big card companies like Visa, you know, they would probably have systems in place that cost millions, and you know, they would not be interested in any of this work, basically. But people who are quite interested in Python and follow PyData talks know that there is, you know, quite a large startup community that you know, cannot afford these big systems, nor have they been around long enough to have the data sets required for some of these systems to work. So when you think about it, a card processing company that would only have you know, this data set, the data set used had 287,000 transactions. A company which would have that much transactions per quarter would struggle with other expert systems. So, you know, there is a niche that needs to be filled for, you know, startups in the payment processing space, that they need fraud detection systems that are not very expensive and very accurate with limited data.
Thank you, Julian. So before going on to the audience questions, so please do keep sending the questions. We're going to try and answer them. So I have one last question for Anastasia. How can this project be further developed for other applications?
So basically, this glove only takes note of American Sign Language, the alphabet. However, it can be further developed also another glove for both hands to be able to actually understand the American Sign Language completely, like actual words. In this case, I couldn't take it that much further because it needs to include.
Okay, seems like
the hand.
Yeah, we lost you for a second.
Sorry?
So we lost you for a very small second. Please go on.
Hi, sorry. So basically, I would need to glove would need to see where it is in comparison to the body, and that is part of the American Sign Language. It could also be developed into virtual reality controllers. Nowadays, for virtual reality, they use actual controllers. But the glove could also be changed into a controller, which would be easier because it would be more intuitive to be able to control a game or play the game basically with just moving the hand instead of actually pressing buttons to play the game. So future development could lead to that.
Fantastic. Thank you, Anastasia. So we have a few audience questions. The first one is from Andre, who is age 12, actually. And he's asking, is that an Arduino LilyPad HID version? I am not 100% sure what this means. So what is this? Any one of you can answer this? Arduino LilyPad
I think it's to me. Yep, it's an Arduino LilyPad, the main board, actually.
So you have to explain to us what that is.
So basically, that is the processor, which I mentioned, that it takes in the information from the sensors, and I programmed it to actually compare the sensor data, and then it would allocate it according to which letter is related to the data obtained. The main board, I chose the main board one because it had the amount of pins I needed, the analog pins, to be able to connect to that amount of sensors. So I had to choose that one. And it obviously it had to be lightweight, and in order for that idea for the glove to be portable, so it was very easy to be sewn in and into the glove and integrated into the glove.
Fantastic. Thank you, Anastasia. We have some other audience questions. Please keep them coming. So, a 6-year-old is asking, how do electronics work? Now, who would like to take that up? Who would like to answer that? In short, in brief, obviously. In very simple terms. Lara or Julian, how do electronics work?
Personally, it's not completely my area, so I think having studied computer engineering for the past 3 years, Anastasia would be the best to mention this. But just to give you a quick idea, we all come from slightly different areas within the same faculty. So although we have a huge interest between us in technology and ICT, the way we apply it and the way we approach it is slightly different. So Anastasia, I think this one is slightly back to you.
Yes, I guess, so electronics is a very broad term, I guess. So from my perspective, my 2 years of computer engineering, it was more seen as the software technology part on electronics. So it was more about the electronics that could be used in computers. It was more hardware for computers. Electronics, I guess, this is a very broad term to explain, would be, the hardware that you use, that you can program and you get information from the surroundings, from the environment, to be able to get information and learn about things around you, I guess. It's a very broad definition, though.
All right, yes. So, Lara, I have a question for you. So how did you get interested in this specific project? When did you first start working on it?
Okay, so my tutor was the person who inspired me the most. His work relates mainly to different relations within images. So he also explored things like relational images, like spatial relations, things like on top of in an image and how those work. And he mentioned to me that this is a particular slight niche in the area which hasn't been explored much. So the fact that these relations do occur within images, but we didn't have, for example, a data set for it, and we also did not know much about how to approach it, fueled me to continue looking into it. One of the hurdles we had to overcome due to this, the context of the area, was that we did not have a pre-existing data set. And since the models we used rely on large amounts of data on images which are pre-labeled, we had to kind of create this from different data sets in order to be able to process and create our models, our programs, which decide these comparatives. So I guess short answer would be the fact that there wasn't much about it, and this was a curiosity of how it could be approached.
Thank you, Lara. And Julian, why did you decide to work on this specific project? Where does your interest start from?
So basically, one of the advantages of the computing and business degree is that you can choose various streams of electives that you want to study, and I chose banking and finance. I decided to go in this area because, first of all, it's quite underrepresented sometimes in literature, and there were certain elements of good timing that a paper was published in the same year that I was doing my final year project, and the paper, as I mentioned in the presentation, actually classified these various oversamplers, ranked them rather than classified them. So that made my work a bit more guided, let me put it that way. So yes, that was the real inspiration.
Thank you, Julian. So with those, we've come to the end of this session. So thank you, Julian, Gabriel, Anastasia, and Lara from the Faculty of ICT. And thank you for being part of this year's Science in the City. So.